There are several use cases for the Home Automation Kit. In this video series, we introduce a weather clock example. It is a clock which fetches forecasted weather data and presents it to the user as a position on a clock. For instance, if the weather is sunny, the clock hand points to the sunny position on the clock. We'll cover fetching and caching weather data, converting the weather data to a clock hand position, adding precise stepping functionality to the motor driver, and using Google Cloud's platform to implement and automate the fetching and updating of weather data. There is an accompanying user guide PDF for a more thorough explanation of all the steps. Before we proceed, the word cloud should be clarified. For IoT devices, the cloud is a remote platform that can be used to offload tasks such as computing, storage, and communications from the microcontroller. This allows relatively inexpensive devices, such as the AVRs, to do computations with the power of a server farm by outsourcing the work. For instance, imagine you want some sort of facial recognition system on an IoT device to identify which user is using the device. The amount of processing required to determine which person a face belongs to is too high for a microcontroller to do in real time. Instead, the microcontroller sends the picture to the cloud, which does all the computation and responds with the name of the person. This is the approach we're taking with the weather clock. Every so often, the cloud fetches data from a remote weather server, stores it, processes it, and sends a clock hand position to the microcontroller. The microcontroller is oblivious to the fact that the clock hand position represents weather data. It just rotates the clock hand to the requested position with the stepper motor. In order to use the Google Cloud platform, you'll need an account. Navigate to cloud.google.com and register. Currently displayed on the screen is a diagram of the complete solution. We will start by having a look at the Iot Core. The Iot Core module handles all the communications with the device. All devices are registered in the Iot Core with a unique ID and authentication credentials. In short, it serves as a gateway between the devices and the cloud. Google Cloud requires every solution to have a project. Create one with a suitable name such as IoT Weather Clock. The Iot Core module can be opened through the menu at the left-hand side. A registry is a set of devices allowing several types of IoT devices to be organized in different categories. This example only has one device and thus only one registry. Press Create Registry and fill in all the fields as such. Select an ID, an appropriate region, and select MQTT. We must also choose a default telemetry topic, which is the default MQTT topic which all incoming messages are published to. Create a topic with the suitable name. Press Create to create the register. All devices in a registry is found under the Devices tab. To add the Iot Board, select Create Device. We need a device ID and a public key value. Both can be found on the Curiosity drive, which appears after connecting the kit via USB. The device ID is found by opening clickme.htm in the URL as such. The public key is found in the file pubkey.txt in the same Curiosity drive. Set the public key format to ES256. The device is now registered in the cloud and can start communicating.